Good day everyone. Good day everyone. I hope you're doing fine. I am back. I'm Gerikanyo and I am your Eucludian geometric teacher. Specializing the only Eucludian geometric in all chapters of mathematics. Tell your friends to subscribe to this channel because I am teaching you this in order for you to get this 40 marks on your examination paper. Cycles are not difficult as they say, but Euclidean geometric needs the full respect that you must give it, because if you don't respect this chapter, it will chow you guys. But hopefully by these lessons, these classes, you'll be able to grab something or grab everything in order for you to get 40 marks. My wish is for you to get full marks, but don't forget to subscribe, guys. Subscribe to this channel in order for you to be able to get more classes and more classes. The more you subscribe, the more I get more encouraged of doing many classes. So today we're going to do theorem 1. Theorem 1 is introduced in grade 11. So theorem 1 has two parts. Can I say parts? But it has two different kind of proving it. Sometimes they will give you a circle like this one, or they might give you the circle like the other one that I'm going to do after this one. But I want us to start with this one. What does this theorem 1 statement says? What does theorem 1 says? It says a line from the center of the circle. This is the line. A line from the center of the circle. Can you see the line that I'm talking about? To the midpoint. Can you see? A line from the center of the circle or the midpoint. I mean, not of the midpoint. We're talking about this line from here. A line from the center of the circle to the chord. This is the chord. If you don't know what is the chord, if you don't know what is the center, if you don't know what is a cyclic or the circumference, go to the previous video. I did a video explaining what is a chord. So going through the last video, you now know what is a chord because I taught this. So a line from the center, which is this one, a line from the center to the chord, perpendicular to the chord. As if you can see this line straight and this one is straight, which means when they join, they do what? They form a perpendicular. So this is what they say in theorem 1. A line, I need you to be copying this to somewhere. You need to copy this somewhere, because nowadays they like to bring this statement and they want you to finish the statement in the examination paper. So you better write this and know it by head. A line drawn, you can say drawn, or you can say the line from the center of the circle. Is this the spelling of the circle? Circle of the midpoint I hope you can see that. A line drawn from the center of the circle or the midpoint of the chord perpendicular to the chord. This is a perpendicular, as you can see there. So we're going to prove this one. They will say you must prove. You have to prove when this question comes, it requires you to prove this. They said prove the theorem that states that, and then they write the statement. So if they ask you a question of proving this theorem when they wrote this is how you must do it. The first thing that you must do, you must do the construction. What is a construction? This is a construction because we have to deal with triangles in order to find the similar lines and angles. This is what I'm going to do. You're going to join MS in order for you to have a triangle, because you cannot prove this thing without making those triangles. So we have 2 triangles now, and then you must write here, you must say construction, what did you join? You must say you joined construction, join SM and TM. SM and TM. So now we are going to prove. When you start to prove, you start here when you're proving. You start by saying what did you construct, and then the second thing, what you're going to do now, you say in triangle MSP, in triangle MSP is the triangle, and in triangle MPT. I hope you can see that. Or this is the good way of saying it. MSP and MTP. You must do like the way you did it in this other side. You must do it at the other side. In triangle MSP and triangle MTP. We're going to check 3 things that are equal to the 3 things that are equal into 2 of these triangles. Sorry. The first thing that I'm seeing there is that MP is common. MP formed the true triangles. This line made this triangle, and this line again made this triangle. So I'm going to say MP is common. That's our first thing that we proved. We have to prove the 3 things. What is the other thing? The other thing is SP is equal to PT. That thing is given. We are not even checking too much there. It's already given. These things, I taught this at the previous videos, or that if they give you this thing, this means that these 2 lines are equal. So SP is equals to PT. Wow, why do we say that? It is given. I think you can see that, because you must give a reason. This is a reason. The common is a reason. Given is a reason, because everything that we do in Euclidean geometry needs to be supported. What is the last thing? The last thing is we have the radius there. Last video I taught. What is a radius? A radius are the lines. Is a line that starts from the center of the circle and ends up to the circumference. That is a radius. And then I taught that radius are equal. So there we have 2 radius that formed 2 triangles, which means SM is equals to MT, which is the radius. Now we have proved 3 things. We have to prove 3 things. We say, because we proved, therefore triangle, you copy this statement. Therefore triangle MSP and triangle MTP. I made a mistake. I'm copying everything. I'm sorry. Triangle MSP. It is. You must be careful. Listen to me very attentively here. Triangle MSP is congruent. We are proving congruence here. These three lines means congruent. They are congruent. MSP, triangle MSP is congruent to MTP. What is the reason? What made us to prove that? You must give the last reason. What made you to prove what you are talking about? So the first thing, MP, this is a side. So we prove in order, we prove with angles and lines. So with angles or lines, it's either angle or line. So what is this? This is a line, or this is a side. And then what is this? This is a side too. This is what? This is a side too. So we didn't prove anything by an angle there, which means it's side, and the number 2, it's side, and the number 3, it's side. This is the last statement. We proved congruency. Congruent or congruence, whatever. But yeah, we proved congruency. This is a congruency. This is the first circle that I was talking about. So now we're going into the second circle of theorem 1. The structure, they bring 2 structures, as I said. So we're going to the second one. Now this is the second circle. Hopefully you guys are taking notes, because as I told you, this thing needs respect. It will respect you too. The aim is for you to answer these questions adequately. And I hope this thing is vivid. You can all see it. Let's continue. So this one also have its own statement. The statement of this one is not the same as that one, but they're not that different. This one says a line from the center of the circle perpendicular to the chord bisect the chord. A line from the center of the circle perpendicular to the chord bisect the chord is the same as that one. A line from the center of the circle perpendicular to the chord bisect the chord. That is the other statement, or that is the statement of this one. So the difference here is the previous circle had things that showed that the arrows that showed that this line is equal to this one. So this one is different. This one has the 90 degree here. You can check. This one already told you that, or tells you that there is a 90 degrees there. By only seeing it, you can already see that that is a 90 degree. So how do you prove this one? The first thing, the same thing as that one. You do the construction. You write construction. Also construction, you join Q, X, and QY. Join Q, X, and QY. What I know about this, from an educator who does go to marking center, Mrs. Mudau, SY, she told me that This statement must be written. I'm talking about a person who goes to marking center here. She told me that if you want to know her, she's Mrs. Mdao SY. I don't think you know her, but just know that this statement is so important. If you just do that construction without writing this here, you are not doing this thing right. What you must do, you must construct yes, and then after write. And you must not write only and not do this construction practical. Do it here and also write it. We need the both things. We need the construction and the writing here. So how do we prove this one? We were given that OR, we were given that QR is perpendicular to XY. That is given. Why do I say that? It's because we have already have the 90 degrees. It is given. You can see it yourself. So the first thing that I can write is that R1 is equal to R2. So you can see what's the difference there. In triangle QXR and triangle QXY, the first thing is that R1 is equal to R2. Why do I say that it is given? That thing is given. Because we know if A is 90, A is 90. It is given. They are perpendicular. And what is the other thing that we see on those triangles? What other thing? We can see that QR is common. And then lastly, what are you guys saying? Yes, that's correct. X, Q, and QY are the radius. And this is the radius. XQ is equal to QY. The reason is what? They're the radius. So what do we say? What do I mean? What is the final statement of this thing? The final statement is that triangle QXR is congruent to triangle QXY. Hopefully you got that, guys. Hopefully you got that, because the circles or the two, because this one is the B. The A and the B circle are not that different. They are the same, just that there is a few things that are different. Then we have to prove the last statement. Why do we say they're congruent? What made us to prove that this thing is congruent? We proved by what is this? R2. This is angle. What is this? Common. This is side. Angle, side. What is this? This side. So there are many reasons. There are many ways of proving this. It's either you can say, let me write it here. It's either you can say angle, angle, side, or you can say side, angle, side, or you can say right. What is this? Right hypotenuse in the side. Right angle, hypotenuse in the side. Yes, I still remember. And then the last one, side, side, side. Remember the last one, we proved the last one by the side, side. This is the right angle, hypotenuse in the side. If you can look at that one, we proved by the right angle, hypotenuse, and a side. What is a right angle? Do you know, guys, what is a right angle? right angle, hypotenuse, and side. Right angle, hypotenuse, and the side. So we prove by the RHS. So, guys, please, 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 go and practice this thing in order for you to be able to answer these questions. If you don't want to write RHS here, you can also write, because this is an angle, this is a side, this is a side too. You can write SES, because we have an angle and two sides. You can say SAS if you don't want to write RHS. RHS only works in this B circle. To the previous circle, RHS doesn't work. So, guys, please respect this chapter. I'm begging you. Please subscribe. I think we'll see each other on the next video. I'll be doing theorem number 2. So, what I want you to do is going to learn these two, know it by head, teach other people or teach your friend in order for you to gain more knowledge, and also tell them to come to the page or this channel to watch the videos. Please guys, anyone who has a question, you can ask the question there on the comment section and I will definitely answer you. So anyone who wants to know or wants to know fully, or maybe he or she didn't understand, must tell me in order for me to articulate myself to you guys. So this is the precise thing that I wanted to tell you tonight. Yes, tonight, because it's already night. So guys, I love you so much. Please subscribe. I thank you.